So I'm back on my Frankenstein EFI, and it's time to start doing some machining on the lower half of my adapter. We're about to use one of my favorite tools in the shop, masking tape. Greetings, fellow DIYer, and welcome to my video. If you've seen any of my other videos, you know that I use masking tape to create lines and edges, and I think it's a fantastic option when working with metal. The reason I like masking tape is, one, you can get it in various sizes. I have 1/4, 3/8, 1/2 inch, 5/8, and 3/4. This all came in a very affordable pack from Amazon, linked below, and it gives me lots of options as far as widths. Now, you're probably thinking, masking tape, what's he going to do with masking tape? Why don't you just use layout fluid, draw lines, that kind of thing? And you can totally do that. But what I like about masking tape is it makes a nice clean line, it's easily removable, and it's easy to work with. So in my case, this is the base that I started with. It's 5 inches wide, it's 1.25 inches thick, and I realized that I'm wasting a beautiful chunk of aluminum. Yes, I know, I already drilled 6 holes in it, but I'm wasting it when all I really need is 3 3/4 inch piece of aluminum. Now, if you do the math, that's 5/8 on each side. And the easiest way to get this lined up with this so that I can clamp it together and use this piece to drill the 6 holes in this piece is to place masking tape on both edges, and then I know this is perfectly centered. So let's get the correct width and use a little tape. I've used masking tape on my hexagon ring project in my videos. I've used masking tape on my carburetor sleeve adapter videos, and this is something that I use almost daily in the shop. If I'm cutting a piece of metal, I use masking tape to create the lines. If I'm working on anything that is irregular shaped and I need 2 lines to be parallel, masking tape is the way to go. Now, masking tape is a little bit flexible, so you definitely want to place it in several spots. You don't just want to pull it tight and go. You will get a little wobble in your line. And obviously, it's not going to be as accurate as a square or a T-square, those kind of tools that are specifically going to give you a line. But that is a nice straight line. Off camera, I added a second layer of masking tape to this piece of metal. And the reason I did that is because now we have a little bit of a ledge on both sides. So just by going 2 pieces of masking tape thick, it is now self-centering. And you push it into position, and now it is completely lined up. Piece of cake, masking tape. One of the best tools in the shop and can be used for so many things. We now have that perfectly centered. Let's clamp it down and drill those holes. Before we get back into machining the middle piece, I want to show you something. Now, this is the piece of the original Ford 5.8 upper that I had machined down and was originally going to use in place of this middle section that I'm going to be machining. From the factory, Ford made these holes oversized. I've got it bolted in all 6 locations, and if I try and shift it forward, it shifts forward. If I go to shift it backward, backwards. If I shift it this way, I can shift it that way. There is a ton of adjustment on these. Now, Ford did that because they didn't care about having absolutely all the possible airflow that they could. And they needed to accept some tolerances because they didn't want to have to be mass producing this, and then matching each one perfectly together. Now, if I stick my hand down in here, I can feel a lip all the way around. These ports are ever so slightly smaller than the ports on this lower. And if you're going to have a mismatch, that's the way you want to do it. You want to have it open into a bigger opening. For this project, because it's going on a 393 and it's going to suck a lot of air, I want to have these ports be dang near perfect. And this little bit of flex and adjustment is not going to work for me, because once I get the middle piece machined, I'm actually going to go in with a die grinder and smooth each bore into this so they are a perfectly matched setup. So to that end, I took a lot of care when drilling these 6 holes. I know you saw me mark the holes using the first piece of aluminum that I started with, and that got me close. I drilled a couple of those holes at 5/16, and the others I drilled ever so slightly underneath 5/16. And then with the 2 holes that were 5/16, I bolted it down. And then I was able to look at the holes and see how much they were off, if there was a little bit of massaging, a little bit of movement that needed to happen. And I used a file to open the holes up in the correct direction to get them to where all 6 bolts fit, but so that it was tight. Then I went through and just basically punched all the holes out with a 5/16 drill bit, and that got me where I needed to be. So let me show you the difference. Now, these are all finger tight. I don't want there to be any clamping force holding this in place. I want this to be located on this based on these 6 holes. And if I try and move it, there is zero movement. I mean, if I grab here to get some leverage, nothing is moving. So I can be assured that if I bolt this on one time and do some port matching, and then I take this off and do some other stuff, come back, I bolt it down, that port matching is going to be identical every single time. And that is super important. Like I said, I need to maximize the airflow out of this intake. And so by doing this way, I have the best shot of doing that. So if I'm so concerned with getting this perfectly matched to this midsection, that means I can't gasket match, because I run into the same problem that I had with this factory piece. Gasket matching has holes that are oversized, and I'm never going to get it perfectly lined up. So how do I transfer this pattern onto the midsection so that I can get it close, and then come in afterwards with the die grinder and clean it up? Should be pretty simple. I have the midsection bolted to this exactly where it's going to go, and I'm going to take some spray paint and spray it down each port and let it dry. And it won't be a perfect coating, but it should tell me exactly where the window is so that I know what I'm working with as I'm machining. We'll give that a little bit of time to dry, and we will get the big reveal. Let's see how the marking process worked. And that's amazing. Now, obviously, it's a little thin on the 2 ends, but I can clearly see where the edge is, which is exactly what I needed. Now, it probably wasn't the best thinking to use gray spray paint on aluminum, but that's not that big of a deal. What I will end up doing is I will go in here with a Sharpie and just gently go around the edge of each of these ports. And then that gives me a line to go up to when I'm doing the machining. My plan for the machining is pretty simple. I'm going to punch out several holes in each of the oval shapes, just using my drill press and a drill bit. All right, we have 32 holes drilled to hog out the majority of the material. And I'm about to take this over to the mill and start cutting in these pockets. Before I do that, I want to give you a pro tip. If you get nothing else from this video, remember this. If you need to drill large holes in a piece of aluminum, use the biggest bit that you possibly can, and use that bit from start to finish. That sounds really overly complicated, and let me break that down a little bit. When working with steel, I tend to start with smaller drill bits, drill a pilot hole, then go a little bigger, and so on. And that works extremely well. That's why step drill bits are so popular, especially when cutting steel. With aluminum, you want to take the size bit that the hole needs to be and drill that in one pass. The reason you want to do that is that right there. Now you're probably really confused. Why is he showing me the scraps that came out when I drilled these? Well, the reason I'm showing those to you is because they came out. Aluminum likes to gum up, even if you're using a good cutting fluid like ATF. Aluminum will get caught in the flutes in a smaller drill bit. But on a bigger drill bit, the flutes are big enough that the material can just curl up and pass right out. Normally when you're drilling aluminum, if you're using a smaller drill bit, you have to go down a little ways and then come back out. Let the drill bit flutes clear, or sometimes even hit them with a brush, clear them yourself. But with this 5/8 drill bit, I was able to just go down. And as I bored into the material, these lovely ribbons came out. And the flute was big enough that they were able to just come out. There was no clogging. To illustrate that, I want to show you. Here we have a 1/2-inch drill bit, and it's got decent sized flutes in it, but they're by no means huge. And then we go to this 5/8. It's only an 1/8 inch bigger in diameter, but look how much bigger those flutes are. And that's exactly why I was able to get entire chunks to come out as I was drilling. It goes faster, it doesn't get stuck, it doesn't gum up, and you get a cleaner hole when you use a larger bit when drilling aluminum. Then I will mount this up in the mill and open the ports up. I'm just about done with the initial machining, less aesthetics. After I've mounted this up and I know that this is going to work, I'm going to take the time and cut these blue lines. Now, these blue lines are an amalgamation of the two gasket sets. We have the TBI gasket, like that, and we have the Ford 5.8 lower to upper gasket. It's important that I have both of these shapes because this needs to be able to seal to the mid plate, and on the top we need to be able to seal to those throttle bodies. Again, that's not something I'm going to cut until I have this working and I know that this is going to work the way I want it to. If we flip this over, you can see, let me turn it around this way, that I did a little more work to it. Now, originally, the roof of the lid was 3/8 of an inch thick. And the reason I did that was because of these 4 stud holes. I needed to have enough aluminum to thread the studs into. But then it occurred to me, all I need to do is leave enough aluminum in those spots where the studs go. And so I came in here with a ball-nosed end mill, and I rounded everything out, made nice round corners. Once all the regular machining on the mill is done, I'm actually going to go in and round off these corners. I'm going to round off the corners around the studs. Everything is going to get smoothed out and blended into the mid plate. And then the mid plate will get blended into the lower intake. All I have to do now is mill out the plenum on this middle section. Because of being able to go deeper on the lid, I don't have to go as deep on the midsection, which I'm thrilled about. I've seen enough videos and dyno testing where just simply adding a 1-inch spacer between the carburetor and the intake adds torque. And so I need to maximize runner length, and I want to keep these runners as long as possible. When it's all said and done, I'm actually going to mill in 3/8 of an inch. That will give me 1 inch of plenum total when you add in the depth here and the depth of the lid. Fingers crossed, that's going to be enough. I really think that if I was taking it above 6,000 RPM, it might be a little small, but because I will be using it at lower RPM, I don't think we're going to have an issue. This will also be milled out around the outside with a ball nose end mill. And again, the purpose for that is to have rounded, smooth corners. When air is flowing, it does not like 90-degree bends. It does not like sharp edges. So everything is going to be rounded, blended, and smoothed. My 3-piece intake is done. Now keep in mind, I did this on a mill that was way too small and not nearly rigid enough. I have everything roughed in. Now, it was all done freehand, so it looks pretty rough. And that was all kind of by design. I left everything just a little bit small so that I can go in with a carbide burr and a die grinder and blend everything together. So I will have a smooth transition from the top plate to the mid plate and from the mid plate to the lower intake. Gives me over 1 inch of plenum between what I have here and what I have here. Everything was rounded with a ball nose end mill, and any sharp edges that remain will be rounded and blended in when I do the carbide burr work. With the rough milling done, now all I have to do is come in with a carbide burr and clean these edges up and blend this mid piece into the top piece here. And then once I've got that blended in somewhat, then I'm going to remove the lid and bolt this directly to the intake and use the carbide burr to clean it up. And we're just gonna blend everything together. Now I have ATF here. I've preached many times about how ATF is a fantastic material when working with aluminum. I discovered that when I was making my adapter to go between the 5.0 upper and the 5.8 lower. I was using this carbide burr and it kept gumming up with aluminum. And it was suggested that if I dip it in ATF, that would stop that from happening. Not only did it stop it from happening, it freed up the aluminum that was stuck in the teeth. So this was all clogged up and it had all kinds of aluminum in it, and I dipped it in the ATF and went back to work, and it freed that aluminum as well. So it works very well. So let's hook this up to some air and see if we can't do a little bit of blending. And just with that little bit of work, you can see how we're already starting to blend into this roof. I'm going to get after this for a bit and see what we can do, and then I will show you the results. All right, I have roughed in the top plate to the mid plate, and you can see where it got opened up a little bit. Now, I didn't blend it in perfectly or completely. And the reason I didn't do that is as I blend this mid plate into the lower EFI, it's probably going to affect the overall shape. So I didn't want to get this perfectly blended to its counterpart in the top plate until I had smoothed everything and gotten it into the lower intake. The other thing that I'm going to do is I'm going to taper all of these. We're going to create a smooth transition from the plenum into the runners. And anytime you can round off corners and smooth things out, the better the flow will be. Let's get back to it. From a functional standpoint, it's done. I've gone in and I've feathered everything on the inside, and I've blended and tried to remove any sharp edges. Now listen to me carefully. If you came to this video looking for a master class on how to do port work, you have come to the wrong place. I have no experience doing port work. I just know that you want to avoid sharp corners, you want to blend things, and I went after it with a die grinder and a carbide burr. This is all done by hand, and there is some general roughness to it. If I was trying to get every last horsepower at super high RPMs, these bumps and these ridges would make a difference. But I think for what I'm going for, I'm just trying to have adequate flow for my 393. And I think with the straight shot in and the blending work that I did, I'm going to get it close. Yeah, maybe I left a little bit on the table, but probably not much. So let's open this up and take a peek on the inside. Before I lift this off, I want to point out that we have sight window from each of the 2 sets of butterflies to all 4 ports on each half. Now, they're not perfectly centered, and we discussed that in an earlier video, but the fact that we have direct line of sight, I think, will help get relatively even flow to all 8 cylinders. And there we have it. Now, this doesn't look a whole lot different than it did right after the machining. You can see there's a little bit of a rough edge where I blended things with the carbide burr. It's no longer straight like it was before, but it now blends to the corresponding edge on the mid piece. I also went in and rounded off corners, again, to avoid sharp points. The more rounded, the more smooth, the better the flow of air. And that right there has been totally rounded and smoothed out. Everything has been feathered more like a velocity stack, and that is going to help the flow and help deal with the fact that this is not a factory piece that has been designed in a computer and all the flow has been maximized. I'm just using the basic technique of make it smooth, make it rounded, do the best you can, and the result will be good. Will it be the most? Probably not. But will it work for this application? Probably. So now that we have this intake basically finished, I still need to do some port work to the lower. If you look at it, you can see where the biggest flaw is in this. Like if you look right here, there's a pretty big opening here, and then it tapers off. And all I'm going to have to do is I'll get my gasket that is designed for those thumper heads that has a pretty good intake window. And I will do gasket matching to open up these restrictive ports on the intake. And as you can see, they're pretty small. Once I get in and I open those up, we should have pretty decent flow with this 5.8 lower. I also want to point out that I was extremely happy with the way the paint technique, where I sprayed paint into the ports to match this to this, worked out. Now granted, we had lots of room to introduce error because the machining was done freehand, but when I came in here with the burr, I barely had any lip to remove. It was actually pretty close and pretty accurate right out of the get-go, and then it didn't take a whole lot to clean it up and get a nice transition from my intake mid plate to my EFFI lower. And that concludes this subsection of my 393 Windsor build. It's been quite a tangent working on this EFFI upper and mid plate. I'm hoping next to get actually into the assembly of the engine, and then we'll be able to install this, get my converted TBIs on top, and see how it works with the Terminator X. I may install this on a 351 that I have sitting on the engine run stand. It's currently the 351 that has the 5.0 upper and the 5.8 lower. And things may not line up perfectly because, as I said before, I custom matched these two pieces to this intake. But if I can get it to bolt up, I may install this on the 351 and hook up the Terminator X and play with it, just to see how it works, see how it responds, see if there are any major issues. And that may be a future episode here on my channel.
If you like what you've seen, please click like. If you'd like to see more, please subscribe. Thanks for watching.